Okay, so we previously discussed the idea of expected utility theory, and we said that when we talk about this, we talk about some prospect, which is a combination of probabilities and outcomes, and with that we can talk about the expected utility of a prospect A, and that would be equal for the sum from I equals 1 to n of pi multiplied by u yi, where the yi's are the outcomes and the pi's are the probabilities. Now, in order to do that, though, we have to think a little bit about some assumptions that underpin this. And the assumptions that underpin this are what we call continuity and independence. Okay, now to talk about these, we're going to have to go back to that idea of a preference relation that we discussed previously. Remember that little funny kind of curvy greater than sign. So imagine three different bundles or outcomes, Q, R, and S. And we say it's true that Q is preferred to R and R is preferred to S. Okay, now we have these three bundles, Q, R, and S, or three outcomes, Q, R, and S. And now we're trying to say, oh, okay, what is the relationship between these in terms of some probability that we could conceive? And so what we say is that if it's the case, so if Q is preferred to R and R is preferred to S, then there exists, so that's what that funny backwards E means, there exists a probability P such that the combination of Q with that probability and the outcome S with the complementary probability 1 minus P, those two as a contingent or as a prospect. What are we saying about those? Those two as a prospect must be preferred to R. Okay, so what's going on here? We're saying a prospect that combines Q over there and S over there with their probabilities P and 1 minus P. We can find the probability P in combining those outcomes such that the prospect is preferred to the certain R. Okay, that's what it means to have continuity. There's a certain R here. Notice there is no probability attached to the R. But in including probabilities now with Q and S, I can say there must exist a probability P such that, with the present preferences Q, R, and S, there must exist a probability P such that this prospect is preferred to the certain outcome R. That's what it means for us to have continuity. Okay, now, that's continuity. There exists probabilities for us to combine different outcomes such that those combined outcomes as a prospect are preferred to some certain other outcome. Now, what do we get with independence? Well, with independence, again, let's think about a preference between two outcomes, Q and R. Okay, now we're going to introduce another potential alternative, Z or Z. Okay, so we're introducing this third thing, Z. I haven't yet made any kind of statement about how we like this outcome Z, right? There's nothing that we're making a statement about in terms of the preferences between Q and Z or R and Z. Just saying there is this third thing called Z. Okay, so if Q is preferred to R, then with a given probability P, okay, P times Q plus 1 minus P times Z must be preferred to P times R plus 1 minus P times Z. Okay, so what's going on here? Well, notice we've got the same probability for P and R, sorry, Q and R in both places. So Q occurs with probability P in the one case, and R occurs with probability P in the other case. And then Z is occurring with the complementary probability 1 minus P in both cases. So what we've done here is we've attached a probability to Q and to R, added an independent, irrelevant alternative Z, which occurs with some probability 1 minus P. Now, if someone is rational, and we're adding in this alternative Z, and that alternative Z occurs with a consistent probability 1 minus P in both cases, then if you prefer Q to R, it must be the case that you're preferring P times Q plus 1 minus P times Z to P times R plus 1 minus P times Z. That's the only way that we can have consistency across these kind of two prospects that we have here, and the outcomes with certainty over here and here. Okay, so these choices that we make must be independent of an additional outcome Z. Now, what we're saying here, which we didn't say earlier, is that if we have preferences such that we have continuous preferences and independent preferences, then we can represent our expected utility of a prospect such as A by the summing of probabilities multiplied by utilities such as we introduced earlier. That's what allows us to create an expected utility.